Alright, good morning YouTube. It is 10:45 on Monday, March the 28th, and I just wanted to do a quick little post and see what kind of comments I get on it, but it's regarding Pacific Coast and possibilities of a Cascadia earthquake, along with some recent things that have come up about with HAARP. And I don't want to get into the whole conspiracy theory of things, but it'll definitely breach a bit upon it. One of the first things I wanted to do was just quickly show you guys that I don't know if you know this, Dutch and a bunch of other guys had put out one of the original websites using the Wayback Machine, and this was just this was back from 97's website that had been posted up there and re-put up there, and just the purposes and objectives of HAARP. One things I just wanted to point out in here was that this was initially a program that was put out by the U.S. Air Force and the U.S. Navy. You know it was put out by the Navy because originally the website was actually on the Navy's website, w3neuralnavy.mil. It's since been changed, and now it's actually a HAARP URL. But anyways, I thought that was interesting. One thing I was noticing with, of course, the earthquakes, and that was Dutch and a few others were talking about with the Ring of Fire, and his concern was, of course, with the large ridge that's along Japan's coast there. The earthquakes that are happening there, it's almost as if there's so many happening that it's almost as if it's starting to crack along that main bed, and Japan has been shifting this way up to 8 feet in some cases were reported. I had the same sort of feeling as well on the Alaska side of things. Alaska is actually one of the largest earthquake zones in the world. They get a ton of them. Not as many seem to report on here. Of course, the more you zoom in, the more show up. But it's the same kind of idea with that ridge. I started looking up stuff just on earthquakes and noticing about the one thing is with the Cascadia zone fault line, which goes from the middle of Vancouver Island and goes all the way down to somewhere in California here. I think it's mid-California or Northern California, sorry, up here along where that ridge line is. So one thing I started doing, of course, talking about those ridges and how they can disappear, I noticed as you go in, I don't know if anybody knew this, but you can actually go in and look under the water, which I think is pretty cool. As you zoom in, you'll notice that there's areas that have been mapped fairly well, and some that are just, excuse me, they're a little bit blurry, like they haven't done any sort of serious mapping on there. So if you zoom in, you get to the water, and of course you get your nice little water moving. But if you keep going down into the water, and then you got to tilt yourself up so you can see what's going on, you can actually see the topography on the bottom of the ground, which is really neat. Again, these areas here aren't mapped as well, and you'll get to areas where you'll see underwater ridges and mountain lines and things. So of course I wanted to see what was up as you get to that ridge, and as you get to that ridge, it's not that noticeable. I mean, you can tell that it's a difference there from where the mouse is down here. We're roughly at about 6,000 meters below, and as you go up, you notice that we're getting closer to land here, and then bang, you'll be up on land. So if you zoom back out, you get a tilt down. We're just getting to that ridge there. Or I guess we're part way up that ridge. So I thought, okay, well, that's pretty cool. You can see how they've done the mapping on here. They do it in sections and grids, not mapped as well, mapped fairly well. So I started looking around, and there's a lot of places where they actually do this fairly well. You can see the lines as you're going in. You'll see these lines of where they've done decent mapping. Now, the one reason why I was saying my conspiracy side of it is, as you actually go into the water, and you'll notice that the Google portion of this is also done by the U.S. Navy. So that's my little conspiracy joined to HAARP there. There's been lots of extra activity happening in the California area recently. They've had those weird sort of HAARP ring anomalies in the weather, and a lot of those happen around those earthquake zones. So anyways, I was looking, and I'm going to try and make this quick because I don't want to be a massive long video, but I was noticing that, you know, again, you can see the individual lines and things, but there's some areas that are actually mapped even better than those other areas. Here you can see not mapped very well. Starting at about midway through California, you can see they've actually started mapping this quite well underground. It actually looks really cool when you're underground or under the water. You gotta look up again. You can see it's not the greatest here, but as you go over some of these areas, and it takes a sec, this isn't the best computer for this, it paints the topography underneath the ground there, or underneath the water, fairly well. What I want to show you though is, it was interesting, out of all the places in the world, you know, Mariana Trench, you've got all sorts of different places you could map. You go map the bottom of the Bermuda Triangle, whatever you want. I noticed that this area is mapped really well. And you can see this ridge line coming up here. I'm actually quite low underground there, but I thought, wow, okay, this looks pretty cool, you know. It's a big ass trench. And yeah, it's mapped pretty well. It won't let me do it because I'm a little close to the edge here. There we go. Sorry for the slowness on this, but so again, if you're looking at this, you can see off in the distance here, it's mapped again really well. I thought, okay, that's really cool. I mean, one, that they're doing that. You know, they started doing it with Google Earth. You can see spots in the map where it looks fairly well done, but you zoom in and you start losing your detail. And the same thing here, you know, you can find spots where detail's pretty crappy, but then you find spots where it's really well, and you can see the definitive lines here. Let me just turn so I'm facing out. So the coast is down behind me here, and this is looking out into the open sea, out in the Pacific. But it's cool. I mean, you can see this line that travels all the way up, and that was just on the other side of that ridge. So I started following it along. You know, again, there's certain areas that they didn't do, but they definitely followed, you know, the ridge line for a bit here. It's pretty cool. I can't wait until they really start mapping the crap out of this. Again, you can see the differences just between these two, where that line goes straight up, and here it's not done as well. Here it's pretty cool. And then I came to this part where it's like a path. I thought, okay, well, let's go follow the path, which came back to here. If I spread that out and go north, you can again definitely see the differences in the mapping that's going on here. So as I'm cruising along, you know, you get some great features, little tiny, I'm assuming old little mountain ranges from before when it used to be land. It just all of a sudden becomes a path, and when you start following that path, you'll keep going. And I just find it's interesting that they've just chosen this odd little path. The odd time it'll branch off. Here we've got two branches going, one off to the east there, one to the west. You go take a peek where they're going with these. And the cool thing is, this one here just happened to come across a neat old ring of 3 extinct volcanoes under the water. I mean, you can see the fact that that actually was a volcano, and you've got, you know, your old the old tops of it. I guess there's more than 3 or 4. But a lot of these, I mean, they're really cool to look at. I'm gonna go up a bit. Takes a while to get used to using a mouse around like that, but you know, this is the old cap of a volcano, so it's pretty cool. And you can see the definitive things there. But again, this is the only sections they've mapped out like this, and it just ends. Actually, it goes off to another little set over here. See if we can follow that properly. Again, why do they do just these one little areas? It's not like there isn't, you know, thousands and thousands of these underground, under the water. But why choose just this sort of specific area? And it's still going. And it's still going. We get to this, and then all of a sudden we got a big field again of sites you can see. You'll see it on the Google Earth if you go to a map and you zoom in towards the water. Looks like we're going off to the east again, and we got another set of some old volcanic things under the water. Again, mapped really cool, almost like they were old and had their tops blown off. And if I just go back to that area, because it branched off here, there was those 1, 2, 3. We got this one right here. My apologies for doing this on the fly here, but I couldn't figure out how to actually map a neat little tiny volcanoes. I couldn't figure out how to do the flyby thing, and it would be tough to narrate while you're doing that. And then the last spot where it comes to is this old area, which actually is a massive caldera from who knows when. So, and then it just ends up here. So if you actually take a peek out, go backwards and zoom myself out, you'll see, you can definitely see how well it's mapped. I mean, it's great, and this is actually what it is. It's axial seamount, and if you were to click on it, it's an old caldera. It does say in there it had some rumblings in the late 80s, early 80s, late 80s. But again, if you zoom out, you'll see there's another area there that's looks like it's a volcanic dome. I won't bother going back under the water, but it is all along this line. Well, when you zoom out, you realize they've mapped beautifully from all those zigzags I took. I'm going to move this over here so you can see this is exactly that North American plate, Juan de Fuca plate. So what they've done there is traveled along that Juan de Fuca ridge, which is right along here, and that's where it butts up against the San Andreas fault, which is, you know, at the end of top of Northern California, which joins up with the Pacific plate right here, Juan de Fuca plate. Ooh, rookie move, sorry. And of course our North America plate up here behind my image there. Again, along with things like HAARP and that, and you start getting more activities and things happening along the beginning of these plates, the one thing that concerns me is, of course, this plate system is exactly the type of plate system for what happened in Sumatra. And with Sumatra, they had 3 plates that were coming together. It's off the west coast of their island. And what was it? It was, I mean, both types are exactly the same. They're subduction zone. It's 3 plates joining. Their rupture that happened along those 3 plates for their magnitude 9, which wiped out 250,000 people, that was a 700-mile section of plate that shifted. And this plate along here from the middle of Vancouver Island is where it actually starts, the Juan de Fuca plate, and it goes down to Northern Cal. There is 1,000 kilometers, so about 630 miles, so roughly the same distance, and we're expected to have a 9.0 as well.